Okay, this session this afternoon is on robot wiring, and Allison Conrad, who is a first alum, is going to be the presenter. Allison is an electrical mentor for team number 6574, Ferrodermis from Whitewater, Wisconsin. She is an electrical engineer at Milwaukee Tool Company, and she is working in the battery department. So again, if you can all keep yourselves muted, because we are recording this session, we would appreciate that. If you have any comments or questions or anything, put them in the chat. Allison has about a 40-minute presentation. After that, we'll have about 10 minutes of Q&A. I will read the questions out of the chat for her. So when you think of something, just put it in the chat and we're gonna get going. So take it over, Allison.
All right, well, hello everybody. Thank you all for being here for the last session in this room of FRC Training Day. As a bit of a brief overview, what I'm going to be going through today are just the components of an FRC control system, what all goes into it, kind of what they do and how they all hook up together. The goal of today is not to be I'm going to learn everything there is to know about how to hook up a robot A to Z. Today is more meant to be a overview so you can have a general understanding of what is going on in your system so that when it gets to the nitty-gritty of actually hooking it up, you have an idea as to what's going on. And I'm going to have some tips, tricks, stuff that we found out on our team mixed in there as well. So let's get started. So this is the FRC control system. This is a guide that is part of the NASA RAP guide that just came out if you are on Chief Delphi. So this is everything that goes in your system. I'm going to be coming back to this graphic in a minute after we've gone through everything, but just it is here. A quick side note to some of the resources that you can look at after today. They are in this top corner. First has a official wiring guide that they release every year on what size wire do you use and what do you plug into what and what color does what, the useful things of not blowing up your system. I would highly recommend checking it out. It can be a little confusing on some stuff, which is why I still like to have these nice big pictures because they can help with the details they didn't photograph very well. And then the NASA RAP guide that just came out, highly recommend. It has more than just electrical stuff in it. It has a lot of really cool stuff. In this presentation, we're going to send out afterwards to teams. Everything is hyperlinked so you can take a look on your own. So let's get started with the most important component of your robot, the battery. So every single robot is powered by these 12-volt sealed lead acid batteries. They are typically the kind of battery style that is used in cars, motorcycles, big heavy automotives. And the reason for that is that they are very, very safe for batteries. They can take a lot of abuse. They can take a lot of temperature abuse. They're good for high schoolers who don't quite know what they're doing to bang around. A couple of notes really quick about charging them. If you happen to be from a rookie team and you are here today and you got one of those battery chargers with alligator clips on it in your rookie kit, please throw that away. And please, please, please think about investing in one of these chargers or similar. These are just on AndyMark. That one's just not safe. We got one in our rookie kit. I don't know if they're still giving that out. But just keep in mind that the battery charger you use can impact how good your batteries will charge. I have seen some teams at competition who have had really, really wacky, scary battery problems because they were using an unofficial, weird off-brand charger. So just something to keep in mind, be cognizant of that. Battery security. So on your robot, at least on our team, sometimes when it's being designed, they don't always think about where is the battery gonna go. 2017, you can see, was kind of a disaster for that. I don't know what other game I've seen where more batteries have fallen out of robots than that one. But just dropping these batteries can be dangerous. They can catch on fire, they can leak. The reason I'm putting so much emphasis on it is just, if you're just getting started, we want you to be safe. So always, always, always make sure it's very secure. So a little bit further on that, batteries are dangerous if you treat them improperly. This was from Pacific Northwest Regional in 2017. where this team's robot caught on fire in the middle of a match. In general, batteries will not explode spontaneously if you take care of them. I've never been on a team where that's happened. Sometimes it's out of your control, sometimes it's a bad battery. It's hard to say. Your safety person should know how to clean up a battery if it happens to crack and spill. That is in the first safety notes if you need them, which is down here. A couple of quick notes from my end of things. Make sure that when you connect your connector to your battery, you do so securely. You want to make sure all the metal on that is covered up. You can use electrical tape, heat shrink, liquid electrical tape, etc. We typically will check on all of ours before competition because your inspector should check on that when you get there, but it's not a guarantee. Never, ever, ever grab your battery by their cables. Doing so can cause damage to the battery itself where the terminals are. It can also damage your cable, which can cause random disconnects between power and your robot. It can cause sparks. It's generally not healthy. Grab it by the base of the battery. Do not grab it by the cord you put on it. And yeah, just check your batteries every now and then. Make sure there's no dents, there's no cracks, there's nothing visibly damaged. If you are no longer using a battery and you have no intention to, get that thing recycled properly. Do not throw it in the dumpster outside your school. That is bad. So a little bit, really quick, this is the last thing I'm going to talk about batteries. You can tell I'm a battery engineer. I'm sorry. Is monitoring their health. Common misconception I see in a lot of teams is that just batteries might just last forever and you got a battery in your kit in 2007. It's still working just fine now. We're going to throw that on the robot. That's not how that works. The more you use a battery, the less power it's going to charge back up to over time. I think the general rule of thumb that I've been told when asking about this is a battery will last, if you're using it throughout the season and competitively, about 3 years is kind of your maximum. But there are a couple of ways to actually check on this and see how your battery is doing. The most expensive way that is easily available right now is just getting a computerized battery monitor. This one on the top left from Andy Mark is the one that we've been using. Basically, it will discharge your battery and graph the power over time as it's discharging. And it will actually let you see how much power your battery can store and how much it can therefore give to your robot. And you can actually monitor and check like, okay, is it good? Yes or no? You can definitively know. We've been trying to do this at the beginning of every season, and if we have time before competitions, it takes a while, so we try and do it before competition season at the very least. A cheaper option that we've also used and still are using is the Battery Hawk. That's this one on the far right. This is made by Cross the Road. It's also sold on Andy Mark, like 80 bucks. It will, basically you plug your battery directly into it. It's a little handheld thing, it comes on a lanyard. And it will give you a read off of your voltage, how charged your battery is, and a general understanding of how healthy it is from like a great to bad scale, a very, very vague scale, but it's something. So it will generally, we use it for just checking batteries before matches, but you can use it to check if something catastrophic is going on with your battery. It will be able to figure that out. The last option and the cheapest by far that I put on here are the Bat Hawks. These were actually developed by an FRC team. They are 10 bucks each, which is a total steal. Basically, you plug them into your battery end and it will just read off what voltage your battery is at. This is really good for if you're at competition and you quickly just want to look over and see which one is the highest and grab it. It's great for that. It's not going to tell you anything about its health, but it will tell you very quickly and easily what its voltage is so you know how charged it is and ready to go. Okay, let's stop talking about the battery for a little bit. Let's get on with the rest of the robot. So this is the main breaker. This is the on-off switch of your robot. It works by you click this little switch into this main oval here to turn it on, and you push this red button down to turn it off. It's a little wacky, but that's how it works. Effectively how it works is it goes between the red wire of your battery and the PDP. So it goes right in between them. And power works by going more or less from the plus end of your battery, the red one, through your entire system and back into the black end of your battery, the negative. If there is any kind of disconnect in there, it's not going to turn on. And that's what this thing does. It basically is just disconnecting your entire circuit and it turns off your robot. Just a little fun power electronics for you there. So all that power's got to get into your robot somehow. So it's going to go into the power distribution panel, the PDP. So your battery power goes in here, and this whole device's purpose is to safely distribute power from your battery to all the components on your robot. So there are a couple of places that it does that. You have these red-black connectors all along the sides. Those are for your motor controllers. Sometimes very specific components need to be plugged in here, like limelight cameras, for example, go in this. And you can plug in breakers into these little slots here. I don't know why this picture doesn't have any. But breakers basically limit the amount of power that one component can draw. So your drivetrain, it's pulling a lot of power, you're pushing somebody. If you pull too much for whatever breaker you put in, it will pop. So you don't break anything expensive. You break your connection for a couple of minutes. Not great for a match, as the drivetrain people talked about in their presentation, but it is a safety feature. Anywho, so you'll also notice that there are a couple of dedicated ports at the bottom here. These are Weldmeyer ports. You don't need to remember the name. These are basically specific connections for required components on your robot. One of these powers your Robo Rio, which is your main computer, the VRM, which is just a smaller voltage device, and your pneumatics control module, which handles your air stuff. We'll get to that in a second. One quick tip, this is a Wago tool, if you were unfamiliar. It's basically a very, very hardened, expensive flathead screwdriver. It is the best way to open these ports to put your wires into them. I got yelled at on our team a lot for using a regular flathead for years before we had one of these. Don't be like me. Get a Wago tool. You're going to break your flatheads doing it. I reassure you, you don't want those metal bits stuck in there. Anywho, so let's talk about the Robo Rio. This is the brain of your robot. It is the main computer. It is probably one of the most single expensive things on your robot. Do not break this. It's going to be a bad time. So when your programmers are actually programming your robot, this is the device that is programmed. It sends all kinds of information to the rest of your system. So it has a bunch of different ports along the edge that you can see. So there's stuff for digital I/O. So if you have limit switches and stuff, that gets plugged in there. PWM is really important. We're going to be talking about that later. And a bunch of other smaller connectors. If you have like one of the for sensor boards, they can plug in here or up in this corner to the side. Just it has a lot of connection for inputs. There are a ton of them. We're not going to go over them all today because of time, but there are a lot out there. So how do you actually connect to your robot wirelessly? Well, this is the radio. It's basically just a very tiny, not the best Wi-Fi router. It plugs in over Ethernet to your Robo Rio right here. And you can just hook up with your programming laptop to your robot and bang, bang, boom, you're off to the races. The other thing that gets plugged into the Robo Rio is the very important signal light. I've rarely seen them break on our team, but I've sure fixed a lot of them for other teams. I don't know what the deal is. But these are just big orange blinky lights. You can see them on here. All they are is they are an alert that is visual to people around the robot to let it know if it's on or if it's off. So if your light is off, your robot is off. If your light is on, the robot is on, but it's not enabled. So like no driver control or anything is running. If it's blinking on and off, that means that the robot is on and it is enabled. So therefore the drivers are taking control. This is more a safety thing by first. It's required. It needs to be fairly visible on your robot. You can have as many as you want, but you're only required to have one. So other required components. This is the voltage regulator module, or the VRM. Basically, all it does is it takes that raw battery voltage that we talked about, and it converts it into smaller measures of power for if you're plugging in not first equipment usually into the system. It does power the radio. Everything else, I think that goes into it, is optional. So I've seen people powering Raspberry Pis with this kind of thing. I've seen people powering the Blinken board by Rev if you want to have fun LEDs on your robot. This is what you use for that. But yeah, everything else is optional. You can put 2 of these on your robot if you really want to. Usually you don't need to. Sometimes people like to have one of them just for their radio because if you lose radio connection, you're kind of just a sitting duck. And one for everything else. We've done this before. Personal preference, honestly. Next up is the pneumatics control module, PCM. So basically everything related to air or like in Ernst's presentation earlier, gets plugged in here on the electrical side. So this is where you plug in your solenoids, your pressure switch, your compressor, and it just gets battery power in for that. This is not a required component. If you are not using pneumatics, you don't need this on there for if you weren't using pneumatics. We didn't in 2017, we didn't need any of this. So just something to keep in mind. Quickly, I'm going to talk about some of these other guys. So pressure switch here, very, very simple component. It's one of the weirdest to wire on the system. It gets connected to these guys. More or less what it does is just make sure that your system doesn't have too much air pressure in it, because if you just kept building up air with your compressor forever, everything would explode, and that's bad. So this is a mechanical system that just closes a valve when it gets to a certain pressure, and it tells the system, hey, stop making more air. Very valuable. Make sure this thing is working. Now we're going to talk about solenoids really quick. And then we're done with air, I promise. I don't want to overlap Ernst too much. So there are two different types of solenoids, singles and doubles. Basically, these control the position of pneumatic pistons on the robot. So in, out, nothing more fancy than that. The red-black wires here go into the pneumatics control module. There is one big difference in that, so they will both go in, out, whatever, when you tell them to. The difference is that a single solenoid will always shift back into its home position when your robot is disabled. So whatever the starting position is, it will always revert to that at the end. Double solenoids, they don't have that constraint. They can end or start in whatever position you set, because they're basically two solenoids. That's why they're called double. For most applications in FIRST, if I'm being honest, a single is enough. We were big dumb and used a lot of these doubles for a long time, and we're just now starting to switch over to this because less wires, you can have more pneumatics. It's a good thing. All right, let's talk about cameras. So there are a lot of different cameras out there in the world. Cameras are really good in FIRST because, especially in games like 2017, 2018, where there's these big structures in the middle of the field, it's kind of hard for your drivers to see around and actually know what they're driving towards if they're on the opposite side, right? So you can use cameras to see in front of your robot. I've seen some people hook up like 360 cameras like on cars so they can actually see all the way around them. Those are pretty cool. We've used them to keep an eye on our hopper this past year in 2020, just to make sure that we weren't jamming and where all of our power cells were in the robot. There are two main types of cameras. There are USB ones, which just plug right into your RoboRio. There are Ethernet ones, which you need to have a switch component on there as well. That's not FIRST official in order to use them because there aren't enough ports for that natively in the system. Ethernet can be a little bit more efficient. You might get a little better resolution. Really depends on your system. FIRST has gotten a lot better about making USB cameras not terrible after 2019 to use, but it's an option that is available. There are also these very special cameras that have vision integration. So if you want to track objects or goals on the field, like you're tracking the power cells, you're tracking the hexagon goal, whatever, you can use one of these to help you do that without needing OpenCV and a bunch of extra code and a lot of extra time. If you are a team that doesn't have a lot of programming resources, these things are awesome. They save you a lot of time, they save you a lot of headaches, but there is a price associated with that, unfortunately. So the cheaper option that I've used is the Pixie Cam. The Pixie 2 is the newest one. It just came out last year, I think. These are really, really simple cameras. There's a lot of resources for how to hook these up to your robot. Basically, you program it using this little button on top, and you just train it to whatever you're trying to get it to look at. They're very, very simple, but teams say they've used them to great effect. We haven't put one on a robot yet, but they are a cool, cheap option to look into. The more mainstream and more expensive option is the Limelight camera that came out 2 years ago, I think. I forget. The Limelight 2 Plus is the most recent. That's going to rack you about 400 bucks. But they are really, really good at just automatically helping you tune your vision system. I've heard teams getting them up and running on their robots in like an hour, and that's not an unrealistic goal. They are very streamlined to help any team be able to vision track if they want to. So just more options that are out there for you. All right, so now we're going to be talking about motor controllers. And I think the best way to talk about motor controllers is to talk about what they're controlling and how they're controlled first. So we're going to do a little bit of a detour towards that for a minute. So as mentioned in the drivetrain presentation, there are two different types of motors that are used in FIRST. There are brushed motors and there are brushless motors. Generally speaking, a lot of this is very general, just keep it simple for the sake of time and for the sake of you don't need to know this in FIRST, is brushed motors are very, very simple. They are usually a lot cheaper, very usually a lot cheaper. They're easier to control. They only have 2 wires coming out of them generally. You put power in red, black, that motor is going to spin clockwise. You flip that connection, your motor is going to turn counterclockwise. There's nothing more funky going on there. The difference is that they tend to get more hot and they are, they're not as efficient, which is where brushless comes in. Brushless motors are a lot more complicated to control, which thankfully FIRST system kind of sweeps under the rug with the libraries on the code end, which is great. They are more expensive, but they are a lot more efficient in both power and heat. And they are usually smaller for the same amount of power, which is a big thing. I'm gonna readjust my Zoom windows to actually be able to show you this. So this right here is a minisim. These are all the motors in FIRST that are typically used with the banana for scale. So this guy right here is a minisim. It has more or less the same amount of power as this Neo 550 over here. You get a lot more bang for your buck for your size and your weight if you go brushless. For example, our robot in 2019, when we put it in the bag, it was 10 pounds overweight, and we were using Sims. We switched them out to original Neos at that point when we got to competition. That alone saved us like 8 pounds. It was ridiculous. So something to keep in mind. And usually brushless has 3 wires. In FIRST, there is one exception, kind of, and we're going to talk about that in a sec. All right, so how do we control motors? Well, in FIRST, there are 2 main types. And I swear we're getting to motor controllers, but this is important to talk about. The easiest way is PWM control. This has been around in FIRST for decades. It's really, really simple. Basically, you just have your little communication wires, the skinny red, black, white ones that come with any spark motor controller you may have seen. This is a way of telling your motor controller how fast you want your motor to go and in what direction. Very generally, within a time interval, so let's say a second, how long that system is high or on or low, which is off, dictates how fast it wants your motor to go. So right here, for example, if you have a signal wave, and that signal is on half the time and off half the time, that's going to tell your motor controller, oh, they want the motor to go at half speed. And then if it's on for 75% of the time and off for 25% of the time, it's like, oh, okay, it's 75, cool. So it's very, very simple, very, very no funny business method of telling your motor controller what it wants. But the one catch with this is that there's no feedback. So you basically are sending your information to the void and hoping that the void is telling your motor to go in the right direction. It can be very reliable, it's fine, but there is a more feedback helpful way, and that is CAN bus. CAN bus are those yellow-green wires that you see on your system. It is partially required by FIRST for some stuff. It's a lot more advanced than PWM. It's common in the automotive industry. They use it for reliability stuff. And it basically works as a really, really bad postal service. This video that I linked down below is going to be a lot more in-depth and better at explaining it than I am. But basically how it is you have your RoboRio, which is this orange box right here. It prepares a bunch of letters with motor controllers' names written on them, telling them, hey, I want you to turn on, I want you to go forward, backward, whatever. And it sends that to the first house. First house is going to look at all those letters and see if there's anything in that for them. If not, they're going to send them all down. If house 2 here, or your motor controller in this case, sees that it has a letter for it, it's going to open it, look at it, and be like, oh, it wants me to turn the motor on. It's going to do that, let your system know, or write in the letter, hey, I did this, and here's where the motor position is, and here's some other information you asked for, and send that down the line. And all that information is going to wrap back around to RoboRio at the end, so it actually knows what's going on. Closed loop communication in a nutshell. So basically this allows for feedback within a system. So you actually can understand, hey, what's going on? The only problem is, like in this example, if the road is closed right here, or you have a wire disconnected in a pure loop style CAN bus, information's not going to transfer, your motors aren't going to move. There are ways of getting around this, such as star topology, if you want to look it up. We've been using kind of a mixed version of that lately. It's a nitty-gritty wiring style thing. It will work, both will work. Just depends on your preference and what makes you nervous and what doesn't. So nothing to worry about for right now. All right, so motor controllers. Yay, we're finally here. So these guys are the things that actually plug into those big red-black connections on the PDP, that power distribution panel. And there are a lot of them that are legal in FIRST. I'm only going to be talking about 5 of them, which are the most commonly used, the most mainstream ones that are still in use. If your team's using something that's not on here, it's in one of the references I posted earlier, but these are the most common right now. So you can see here, communication method we just talked about. A lot of motor controllers are using CAN PWM. Spark Maxes can also use USB. They have a USB-C port on them. You're not going to be using that on your robot, but you can use it for testing and getting them set up in the first place, which is very helpful. So for brushed motors, you have Talon SRX, Victor SPX, pardon me, Spark motor controllers, and the Spark Max, which can do both brushed and brushless. And then for brushless motors, only the Spark Max and the Talon FX on this list can do that. The reason I had that asterisk next to 2-3 wires earlier is because the Talon FX is built into a Falcon 500 motor. Only 2 wires will come out of that thing. It's because they're integrated. That is the only reason. You're just providing it power, not anything else. In general, brushless is going to be more expensive in FIRST than brushed in a general sense. All of these motor controllers and motors are great for what they are. And there's a little description here that we're not going to get too into. I'm not going to tell you what to use on your robot. It depends on your resources and what you feel comfortable doing and what you have available, especially this year. So this list is available. If you have questions later, we can talk about it a little more specifically. So let's look at how everything hooks up really quick. So we've gone through everything individually. Now let's smush it all together. So we have our battery, which is over here to the battery. Goes into the breaker only on the red wire, and both of these guys get plugged into that PDP. So you can see a bunch of breakers on here, which are connecting up all these motor controllers, the different limits of how many amps they can draw, how much power they can draw from your battery, basically limiting that so you don't explode anything, you'll be fine. So all of these guys hook up into here. Down here at these Weldmeyer ports, you can see that we have the pneumatics module, voltage regulator, and the RoboRio. That RoboRio has its radio connected over Ethernet, and it's getting its power from the voltage regulator. Cameras can just get plugged in via USB right here as well. And the signal light gets plugged in RSL. There's a very dedicated port just for it. On the pneumatic side, we have our solenoids getting hooked up into these ports labeled 0 through 7. You have your air compressor, which we didn't talk about too much because it is a device that builds air. There's not much else to it. And then that also connects up to that pressure switch that we talked about. And then there are some other little things you can hook up, little servo motors and stuff, all kinds of little digital things can hook up into the RoboRio, depends on what you're using. And then there's CAN bus, this yellow-green stuff here. That is connecting in a loop throughout your system. So you can see it goes to the pneumatics module. It goes into the PDP right here. And it also goes into each of the motor controllers and then back out again. These guys over here, these are PWM. Well, the SP is an older version, but whatever. These are these red, black, white wires I talked about. They go into the PWM ports on that RoboRio instead. So generally, that is how everything is hooked up. You look in the wiring guide, reference this picture when you're actually doing it. But in general, that's kind of how everything is hooked together. This way of hooking things together is more or less required the way it is by FIRST. So there's not too much meat and potatoes of anything going wrong here. Okay, So really quick, I want to divert and talk about just the actual act of wiring your robot is different depending on every single robot that you're going to have out there. What you don't want to do is be like us in 2018, making this spaghetti nightmare festival down here, which we actually competed with, and it still went to Worlds. Don't do that. We wired this thing right at the bag day. It was a mess. That's how it goes sometimes. Cable organization and keeping everything nice and clean is extremely important to the reliability of any robot. I cannot tell you how many times I've been chewed out by our drive team because a wire popped out, just a little tiny whatever wire, and it cost us a match. It's not fun. It's not fun for your team. It's not fun for you. It can also be a safety concern. Loose wires can cause shorts. It can cause fires. It can cause brownouts, which is just your system is getting really weird voltage levels. You don't want loose wires in your robot anywhere. You don't want exposed metal. Metal exposed is bad. Loose wires are bad. So in general, I have 2 rules of thumb for any team. You can't debug what you can't see. So if you cannot see where your wires are going or what they're connected to, you cannot debug something quick enough for your team to be able to get that thing back up and running fast. And you can't fix what you can't access. We actually ran into this issue last year. A lot of our wiring was underneath our spindexer, big polycarbonate circle in the middle of our robot, and getting your hand under there to fix anything was awful. If you cannot get to your wires, you can't plug stuff back in. It's just physically not how that's gonna work. Now, saying all this is all nice and dandy. Actually doing it is another thing. So there's a couple of little tips, things that I've found over the years that we're going to talk about on how I've gone about fixing this in the past few years. So first, we're going to talk about connectors. There are 3 main categories: heavy duty, medium duty, and light. Heavy duty are your battery connectors. These are required by FRC. There are only 2 of them, I think, that are out there. The most common are these SB50s. They are for 6-gauge wire. The thickness is the gauge. These guys, sometimes they're pink. I don't know why. You are also allowed to use 4-gauge wire, which is a lot thicker. It's not as commonly used, at least in Wisconsin. I haven't seen it. I've seen it a little bit in teams online. This is also legal. Look into it before you start buying stuff for it. Medium duty stuff. So this is for your motors, your motor controllers, the big chunky wires on your robot that are the most common. There are 2 main ones I've used and I've liked. XC60s are these yellow ones here. They are used in RC a lot. They got a male and a female end. They are fine. They're pretty cheap. My favorite though are these Anderson power pole connectors, the red black ones over here. They are non-gendered, which means that you don't have to worry about having a male on one end and a female on the other. You just put them on and they work. They're great. There are 2 different styles. The one most common and first is a crimp style. Andy Mark sells a kit for this. It's expensive, but it's nice. Also, don't tell anyone I mentioned this, but if you email Anderson Power Pole, you might be able to get some for free as a sponsorship. So just saying. Both of these are really good. They're very successful in first. One thing to keep in mind though, I've seen a lot of counterfeit ones on Amazon of both of these. Please be careful. If you do, sometimes they don't connect right or stay right. So just keep that in mind. Light duty stuff. So connecting your CAN bus, connecting your lower voltage stuff, connecting your radio, basically anything with a smaller, thinner wire. There are tons and tons and tons and tons and tons of connectors for this. I'm only going to talk about my favorite ones today. So first off, ferrule connectors. These are a little newer in first. They're these guys over here. For those Weldmeyer ports, those little white squares, sometimes it's really hard to jam a wire in there without it fraying out and sticking everywhere. These just crimp onto the end of them, and it gives you a nice little square that you put in a hole. You got to be careful because they can slip out real easily if you don't do it correctly, but they've been really nice for making sure that we don't have any frayed, sparky anything going on in our robot. I like them a lot. There's also Wago lever nuts. These guys. They're 2 different styles, but first off, these ones just connect everything that gets hooked into their little box together. So if you have CAN bus wires that you need to hook up, these are really nice for that. So you have one for your red, one for your black. Specifically for our CAN bus and for a lot of other 2-wire applications, we use these guys. They are also technically Wago lever nuts. I think they have a different brand name in there. But they are inline. So they just go, let me move that, red to red and black to black, or green to green, yellow to yellow for CAN bus. And they're really easy to use. You strip your wire a little bit, you put it in there, you snap it closed, and you're done. We've used these on our robots for the past 2-3 years, and they've been great. We haven't had any issues. I love them to death. Please look into them if you want to hook up your CAN bus in a quick and easy way. They're also great for prototyping. The last thing that I want to spend some time talking about today are some of my favorite ways to manage cables. I'm pretty sure that most teams here know what a zip tie is and the values of zip ties. They're very good for just bundling chunks of wire together and just making them all nice and straight. Another way, there we go, are Velcro straps. These are kind of like reusable zip ties in my mind. They're just a Velcro strap that loops around your wires, can cinch them. They're really nice for just prototyping and hooking stuff together when you don't want to cut off 30 zip ties at the end of it. There's also, if you have a robot that doesn't have a lot of good places to zip tie your wires to or to mount to, or if you just have a big old rectangle, these are cable mounts. They're also cable clips. So these have a little sticker pad on the back, and they will just stick right to your surface of whatever you're using. And then you can just run a zip tie right through there to clip your wires on like that. Or you can just use these clip style and just snap your wires in. In first, I will typically use these cable mounts a little bit more because I never know if I'm going to be adding more wires later because I don't plan far enough ahead. But both of these are really good options for that. It's just a preference thing and where it's going. There's also cable spiral wrap. So if you have, 10 different wires that you want to just kind of bundle together and keep all in one group, spiral wrap is great for that. It basically is just plastic that just zoom around all your wires, and you can pull ones out as you need. It's just nice to keep everything together. That's not just 8 billion zip ties. This is more for elevators. I've heard it used on turrets too sometimes. This is energy chain or cable chain. You run your wires through the middle of it, and it kind of restricts how your wires can move up and down. Some people, if you have CNC machines or similar around, they use this. Cable raceway is more used in PC or big PC tower, IT tower kind of development. They're these plastic tracks with a lid on them. So you just put all your wires in the track and they come out through these little holes, and everything just kind of stays in the magical mystery box and you don't open the box ever. Looks really nice and does help keep things together. It's just finding a small size of this can be kind of screwy. You might take a couple of Google searches. I've included a link to one I like on here. There's also this neoprene cable sleeving. We were actually using this for our turret. Basically, it's just a big sock type thing. You wrap all your wires up in it. It has Velcro and it just kind of sticks around everything. It's also great if you have 1-inch tubing. It will perfectly fit in here with a couple of wires, so you can just wrap around the whole thing, and it keeps everything nice and sleek and together. I haven't seen this used too much in first, but I really like it. People sleep on neoprene sleeving. It's great. The final thing that we've been using a lot more recently, we used it a bit in 2019, are these VR cable pulleys. They are very, very similar if you have like a work ID badge or anything on those like pull string type things. These are great for keeping wires out of places that they shouldn't be. So we used it, for example, in 2019 to keep our elevator wires getting to the elevator out of the rest of our system. We've been trying to use them as well for keeping wires out of the rest of our system when our turret is spinning around at 1,000,000 miles an hour. They are just really nice at allowing your wire to pull itself towards something like a turret, or if you have an arm going out or whatever, but it'll keep it retracted back when that mechanism pulls back in. So it gives your wire a little bit of freedom, but not so much that it's going to get snagged into everything. So I like these a lot. These are just like higher quality ones. They're really not that expensive though. Okay, I think that's all I had for today, and it seems like we're right on time. Does anybody have any questions?
Oh, Allison,
Yes.
this is Jane. I guess I should turn my camera back on. There was one question. It says, will the wiring tutorial include how to make a robot wiring immune to ESD? I don't know if you discussed that.
I can read this and I got it.
Okay.
So for those of you who are unaware, ESD is electrostatic discharge, I believe is the correct acronym. Basically, when like the effect of when you rub your feet with socks on them on carpet and then you zap your friend, that's ESD. It's a really big problem if you ever work on circuit board development because the components are so tiny. Even the littlest zap from you in winter especially can cause things to break, and that's not great. We've actually had issues with this on our robot in 2019 Duluth when we first installed those foam floor mats that you can kind of stick together, like for workouts and stuff. We were zapping the bejesus out of our robot so much with that stuff. We have since reconfigured it. It's fine. So one thing I've seen a lot of teams with those mats on their floor of their pits. If you are noticing that you are shocking people, and that is the case, just basically don't put pads down in the track where you put your robots. So if you have a 5x5 grid of those cubes on your floor, get rid of 2 of them in the middle. That's where your robot cart goes. In general, so just reducing ESD effect on your Robo Rio. The Robo Rio itself is really tolerant of a lot of garbage because it's designed for high school kids. I don't know if your team specifically has had issues with it. We haven't really noticed too much of a problem. Oh geez. Now plastic construction causes ESD. So in general, all I can really say to that is when we mount our Robo Rio, I will usually just use Velcro. Strap it down to something not metal is a big one. So we have it on just a slab of plastic usually. This year we had it on a big chunk of wood for our belly pan of our robot. Keep it away from metal, keep it secure. And in general, you want to make sure that if it's in winter and people are touching your robot, just touch the frame, touch a metal table, touch something before you mess with your Robo Rio. That'll discharge any electricity in you. And you don't need to go out and buy any of the equipment for ESD outside of that. I've used it, it's kind of overkill for first. I don't think it's too much of an issue there. I think I've covered ESD as well as I really can for this one. I might come back to it if we have more time later. If we want to use pneumatics with the PCM, will we not be able to use spark motor controllers? No, that's totally fine. Using pneumatics in the PCM uses CAN bus communication. That is a requirement by FRC. That is just how they're hooked up. You can use any combination of CAN bus and PWM that you want. They don't care. So if you have, 16 spark motor controllers and then you hook up your pneumatics module over CAN bus, that is totally fine. The Robo Rio will handle that for you. It's cool. So you can do that. It's 100% okay. We've done that mixed before in 2018. It's totally cool. Couldn't you use ground brushes on the chassis to drag on the floor surface? I've seen some people doing it. I haven't really noticed too much of an issue with it. It's kind of the problem that I run into with the weird ESD-ness. I have seen some teams do that, but if you use the wrong material, you could be generating more static than you're discharging, which is bad. So general rule of thumb, keep it away from anything that might be causing problems. We tend to keep ours in kind of a very secluded part of the robot, which, depends on the shape that your CAD people and build people made it, but keep it away from things, keep it away from exposed wires. In general, another thing that I will try to do is keep it away from things that are hot or noisy. So if you have really big chunky motors on there, say you have a 6 Falcon drivetrain, try to keep it away from those if you can. The vibrations can kind of screw with it. And the compressor itself can get really, really hot. That's normal. It does that. Hot things plus expensive electronics usually equals bad, so try and keep that away from there as well. Okay, are there any other questions? Or questions to the questions? That is also okay. Worst case, throw them in the chat. We'll be hanging out here for how much longer do we have? 4 minutes, according to my timer, I think. Yeah, I'll be here. If you think of anything after this meeting or you want to talk about anything more in depth, my email is on the schedule. Feel free to shoot stuff at me whenever. It's totally fine. I love helping out. It's totally cool. In any case, I hope all of you have the best season that you can possibly have this year. If you have access to your robot and you're actually going to use some of this wiring stuff, all the more to you. Make the best of this year. Do what you can. If you forget everything after this presentation, it's recorded. You can watch it again anyway. It's totally cool, but I hope you all have the best of seasons in any case.
Well, thanks, Allison. We appreciate all your knowledge and sharing with us today.
I have one more question, more comment than question.
Sure.
For ferrule connectors, yes, some crimpers are better than other. I linked one that I like on there. Keep in mind that a kit of those things with the crimper is like 20 bucks on Amazon. Ours is okay. I'm sure there are some that are better. A lot of that kind of thing is just kind of trying to figure out what works for you and your team. But yes, that is a problem. Sorry to interrupt you, Mrs. Black.
No. No, I want you to answer the questions. That's what you're here for. So we've got, Emma says we have 3 more minutes. So if anybody has a last question, comment, whatever, please throw it in the chat now. Then we're going to go back and just have a few quick announcements. And Emma's going to pop up the post-training day survey. We would really like it if mentors and students and anybody who's watched any of the sessions can please fill it out, because that will help us make the next one even better than this one. You know, we're here to supply the information that the teams need. So.
Yeah, and there are a lot of resources online for all of this kind of stuff. Obviously, a lot of people have been linking them in their presentations. Go look at those. There's only so much that we can cover in 40, 50 minutes, given the time frame. Nothing that we're going to say today in any of these presentations is the end all be all of that one thing that we're talking about. Do some research, be curious, look into other people's things and what they're doing. There's a lot of really cool things that are out there. And first, I highly recommend you go and look for them, especially if you are not on Chief Delphi, which is the forums of FIRST. Definitely go and look on there. You can just search in Google, it'll pop right up. Any question that you have that I can't answer or you have on something else, you can put it on there. There are people all over the world who will be happy to answer your question. It's a really good resource.
Okay, it looks like our room is going to be closing very shortly. So if you can all join us back in the main room for just a few minutes, we'd appreciate it. Thank you, Allison. You did an awesome job, and I really appreciate you sharing your information with everybody.
No problem. And thank you, everybody, for coming. This was a lot of fun.
Oh, I got to stop the recording.
Turn off the pointer.
All right, I'm